This PhET simulation has been built to mimic a problem that I have as part of the physics workbook, where you have sort of a simple circuit where you have a 1 ohm resistor, and I can click on here, see it has a 1 ohm resistor, then branches into two individual 1 ohm resistors, and then that comes back together into another 1 ohm resistor. And this circuit is driven by a 10 volt potential difference. Now, the purpose of this question is to actually get us starting to think about actually a fluid system, the circulatory system. And many of the ideas that we're going to look at with current and electric potential drop are very similar to what we're going to get when we look at flow rate and pressure drop. So when I connect this circuit, what we can see is we have this flow of electrons that comes from the negative terminal of the battery and is flowing through here. And if we want to measure the current at different spots, one of the activities in these worksheets was to make that calculation. This is going to be a check of that, where we can see we get a current of 4 amps through this resistor. And the other resistor in series is also at 4 amps, so we should expect both of those are at 4 amps. Now, given two identical resistors, we would expect that that should actually split 2 and 2, which in fact it does. So 2 amps and 2 amps. And hopefully you were able to show mathematically that that would be the case. Now, an interesting thing we can do here is we can take one of these two central resistors and we can increase the resistance. Now, in that sense, that's going to mimic what in the circulatory system we see as maybe a clogged artery. Some kind of stenosis, some kind of thickening that may happen in the artery that reduces the radius of the artery itself, and that increases the resistance. It slows the blood flowing through that particular artery. So this can be a great analogy to think about what a blockage might look like. And the way I might do that is say, well, let's go from 1 ohm to 10 ohms. Let's say the resistance goes up by a factor of 10. So I slide this up. And so what we can see just visually is that the current remains going quickly through the rest of the circuit, but the charge moves really slowly through this resistor. Now that's expected from what we've seen in circuit physics at this point. So okay, great. There's this one vessel where maybe there's a slower blood flow. Now that might seem like, okay, that's not that big of a deal. But if we measure the current, we're going to see something important here. 3.44 amps. Now, if you remember, when the resistance of this upper one was just 1 ohm, the current through this entire circuit was 4 amps. But now, because there's this one resistor that has increased resistance, now it looks like everything else is flowing along nicely, but the overall current, the overall flow of these charges has reduced. So in the body, you would find that in the circulatory system, the blood flow rate would be reduced. Now, that's not really an acceptable case. The body needs to maintain a particular flow rate in order to get nutrients to the rest of the body. So if there is a closure at one point in the body, if there's a slowing down just in a single vessel, that's going to affect the entire circulatory system. That's going to change the flow rate everywhere. So now this current is a little bit less. And yeah, where here before we were getting 2 amps, well, in this case now it's 3 amps, where it's a very small amperage here. I mean, the body is much more complex than just this. But this example gets to this idea of what happens if we increase the resistance at one spot. What is the overall effect of the body to the body? So one thing we could do is, if we want to get the flow rate back up to 4 amps, get the current back to 4 amps, one way we could do that is we have to increase the voltage. So if I want to get this up to 4 amps, I'll take this up to about 11.7 volts. So I need to increase the electric potential difference. In the human body, that would be increasing the pressure difference, the pressure gradient that comes from the heart. That would be like increased blood pressure. Now, one of the things that actually happens in the body is, up to a point, is something that's called autoregulation. So if there is a blockage here at this point, there may be some vessels downstream which actually open back up, that actually open up a little bit. they can dilate. So actually, maybe the resistance downstream, there would be this vessel that would decrease a bit. So this resistance is going to drop to, let's say, 0.6 ohms. So downstream, this vessel opens up, and that allows the current to flow a bit faster again. So that will keep the body from needing to necessarily increase the potential here. But at some point, the body can't keep doing that, and then you have some bigger problems. So this is how a very simple little circuit like this in electrical circuits is able to start helping us think about some of the complex fluid physics that we will take a look at with the circulatory system.